All right, so the next topic we're going to talk about are quadrant angles and reference angles. So the first thing we're going to really talk about here is reference angles. A reference angle, so really a reference angle is going to be used to help us find, when we're talking about angles that are larger than the first quadrant, that are not acute angles. So if we have theta being our angle in standard position, its reference angle is the acute angle, acute meaning less than 90 degrees. We call that theta prime. That little tick mark means prime, okay? And it's formed by the terminal side of theta and whatever's the closest horizontal axis to it. So again, we call this theta prime. That little tick mark means prime. And we're looking for the closest horizontal axis to it. So if I take a look at the angles here, in my first quadrant, I'm already acute. So the reference angle really is the exact same angle as the angle I'm dealing with. We don't really need a reference angle. So there's no reference angle needed here. But technically, it is equal to theta. Theta and theta prime are technically the same angle here. We just don't need one. If we take a look at the second quadrant, however, if I wanted to find, say, sine or cosine or tangent of something in that quadrant, it's going to be a lot more difficult because it's not an acute angle. I can't just draw a triangle to make this happen. So what we're going to do is take the terminal side, which is in the second quadrant, and we're going to bring that to the closest x-axis. So the closest to form an acute angle would be this way, okay? That angle right there is going to be my theta prime. So in order to figure out how big that is, what we're really going to do is say that our theta prime is going to be equal to, whether you're in radian or degrees, you can do this, pi minus theta, or you could do 180 degrees minus theta. So really we just want to figure out how big is that red portion. If we subtract the purple part away, then we would have just the red part there. All right, let's look at quadrant 3. So when I happen to be in quadrant 3, the closest way to the x-axis from the terminal side is kind of going backwards. So that part, that red, will be my theta prime. In order to find that, we know that it's bigger than that 180 or that pi. So if we take that pi or 180 away, we'll be left with just the red part. So that means that theta prime would be equal to the original angle minus pi, or we could say minus 180. And then lastly, if we're in the fourth quadrant, what we really want to do is kind of finish up the circle. That's the angle that we're talking about. That's our theta prime. So what we would do is just say 2 pi minus the original angle, and that'll tell us how much more there is to go. So theta prime is equal to 2 pi minus the original angle, or we could say 360. So what we're going to do is find the reference angle and sketch both of them. Eventually this reference angle is going to really help us to figure out sine, cosine, and tangent, but we're not there today. All right, so let's take a look. We're given the angle 300 degrees. So we know that 300 degrees has to be in the fourth quadrant, right? It's almost 360. So here's my initial, my terminal, so 300, somewhere about here. So here's my 300 degrees, my theta, that it equals 300 degrees. We want to know what is the reference angle. So again, remember the reference angle is going to come in by going from the terminal side to the closest x-axis. That would be from this terminal to the closest x would be right there. That's going to be my theta prime. Now, this number might be pretty easy because the number is not too terrible that I'm working with, but it's good to go through the actual formula for it. So because I'm in the third quadrant, I am going to do an entire circle minus the original angle. So my theta prime is going to be equal to 360 degrees minus the 300 degrees for the angle. So that's going to give us that theta prime is going to equal 60 degrees. Okay, so this little portion really finishing my circle is 60 degrees. All right, kind of the same concept. I know they're alphabetical going down, but I'm just going to go across. So I'm going to do D next just because it's closer. So let's graph what we do have. We are given 213. Now, I don't know exactly where 213 is, but I do know that 180 is over here on the left and that 270 is down here at the bottom. So it has to be somewhere in quadrant 3, probably a little bit closer to the 180. So here is my angle. That is theta, which is 213. I want my reference angle, which is always going to be closer, right? We're going to go the closer direction to the x-axis. So it is closer, it is acute on this side. So that's going to be my angle. And I can do that by subtracting pi from it, or in this case, 180. So theta is going to equal the original angle, which is 213, minus 180. So really, depending on the quadrant, is going to tell you which formula you're using here. So 33 degrees. And you can kind of do it by eyeballing. It kind of makes sense here. We're going to take away half of a circle to find that little red portion on the graph. All right, this is a little bit trickier. So we want to figure out 2.3. Where is 2.3? 2.3, it doesn't have degrees, so we must be referring to radian. 2.3 radian, normally we see the pi symbol. We don't see pi here. So let's think about this for a second. If I have pi over 2 is here and pi is over here, that means pi is about 3.14. So half of that would be about, I don't know, 1.74-ish, right? So we can figure out just kind of by eyeballing it. It's got to be in quadrant number 2. All right, so our initial and somewhere in quadrant 2. Okay, so there is my original angle, 2.3 radians. All right, so now I want to find the reference angle. Again, for the reference angle, I'm just going from the terminal to the closest x-axis. That would be down. That would be this red portion. That's my theta prime, and I just have to subtract. So I'm going to do pi minus the original theta, and that'll give me my theta prime. So pi minus the original theta, which was 2.3. We're going to get an ugly decimal here, so we're going to only get an estimate. This is going to be about 0.8416, and it keeps going. So, I don't know, something along those lines. Okay. Again, in E, same kind of issue here. I don't see the pi symbol, so I'm just kind of estimating about where it is. Now, 1.7, let's see, 1.7 is going to be, we said that we had pi over 2, so that would be 1. Oh, did I say 74? I'm sorry. I misspoke before. When I cut 3.14 in half, let's see, 3.14159 divided by 2, that's more like 1.6, sorry. Or 1.57, I guess I should say. Sorry, have my numbers backwards. All right, so again, we have pi over 2 at the top, which is really like 1.57. We have pi over on the left. We know that's about 314. So we want to figure out where to graph 1.7 radian. That, again, is going to be somewhere in that second quadrant. So there's my theta, and that is 1.7 radians. So now what I want to make sure I'm doing is going to the closest x-axis. So that would be completing that half of the circle. So we're in quadrant 2. So what we want to do is we have our angle is going to be equal to pi minus the original angle, which was 1.7. And again, when we subtract, we're just going to get a horrible decimal here. That's about 1.4416, and it just keeps going. Okay. All right, so the next thing we want to do, let's take a look. What if we have a negative angle? So if we have a negative angle, we have a few options that we could do. One is that we could just figure out what's a coterminal angle to it. We could absolutely do that. Or we could graph it. It doesn't matter. So you might be familiar, sorry for the beeping, with the unit circle. That 135 is one of those like pi over 4 numbers. So if it's negative, it's just going to be down here. So there's my negative 135 degrees. Okay. To get, again, the same kind of thing, to get our reference angle, we're going to go from the terminal to the closest x-axis. So I just have our, this is where things get a little bit messy, but I have theta prime. I need to figure out how big that is. So this is where things get a little messy. I can't just easily subtract stuff here. I need to kind of think backwards because I want my reference angle to be a positive angle. If I think of the fact that this black portion of the angle is really 135 degrees, I just went down, and that's really all the negative means. I'm still going to do half the circle and remove 135. That's going to give me the red portion. So if I do half the circle, which is pi, well, actually, we're in degrees, so it's 180, and remove that black portion, so I'm going to take away the 135, that should leave what's left in red. So that means theta prime should equal 45 degrees. So even though I was dealing with negative, I just want to make sure that when I'm looking at this, I'm kind of thinking through it logically. So even though I went down first, I really could have thought of this as a different angle. So I'm almost thinking of this as like negative quadrant 2. I know that's not technically what's happening, but this is kind of like the reverse quadrant 2, right? If I went backwards, this is what would be happening. Okay. All right, and let's take a look at that last one. We have for quadrant 2 here, right, we're going to land in quadrant 2, 144 degrees. That's somewhere between 90 and 180. So there's my theta, whoops, there's my theta, and I want to find my reference angle. So my reference angle is the closest way to the x-axis from the terminal side. There's my theta prime, and I'm just going to do 180 minus that angle. So minus the 144. So I'm going to get that my reference angle here is going to be 36 degrees. Okay. What this is going to help us with down the road